It's on Zoom. Here, maybe this works now. It seems to work, so you don't have to necessarily come to this class. So you could come online or you can be in the class. And I also record one of these lectures, so I'm going to post that on YouTube. So if you do miss for whatever reason, I prefer everyone's here kind of in person, but I get it. You get hammered or something, and you're hungover. You don't want to come to my class. I get it. You weren't hungover? Oh, okay. Well, we'll see. Or we'll see if you do it again. No. Anyway, let's talk about this stuff. So as a reminder, Visual Studio Code, if you open it up, make a new file. You can follow along if you want. I just made a file called server.js. It doesn't have to be called this. You can run any Node program in any .js file. But again, these assignments moving forward, I think there is a server.js file, so I'm just going to stick with this. The reason is because we're going to make a web server eventually. This is just for practice right now. So if you make server.js and then you open up console or terminal, and if you type in, in your server.js, console.log, hello world, and then just run your server.js, you should get hello world. An interesting thing that you'll see me do is I have this program called NodeMon, like Node Monitor. And this program, you can download it with NPM. I'll drop it into Discord. And what it does is every time I make a change to my file, it will automatically recompile it and run it for you. So you don't have to constantly go to terminal and type node server.js. And so you just type NodeMon and it should run. That's what you'll see on my screen if you're not doing it, but that's why it's green. And then it runs the code. Again, I'll drop it into Discord here. If I can find the link. Right here. So let's talk about console for a second. Like, what is console? Or command prompt? Terminal, what do we call it? Where did that come from? Where is that? Like, who invented console? Is it part of Node? Is it part of the system? I don't know. Anyone have a guess? When you open up on Mac or Linux or whatever, you get this terminal. You can do stuff like dir or ls, things like this. Or same with command prompt, right? You can do ls, dir. What is this? Any ideas? Never heard of this before? I'm sure you've heard of command prompt before, right? Well, if you are on a Windows machine and you open up, I don't have one here, but if you open up Explorer, like File Explorer, and you go to C Windows, and then go to the System32 folder. And if you open this up, you should see something like this. And if you look at the bottom, it should say like 4,000 files or something like this inside of this one folder. And this is basically where Windows lives. And all those DLL files, they call them libraries. We call them in Node modules. And you can see exe files, you can see calculator and all this kind of stuff. And this is kind of what powers Windows. And you'll see the console terminal thing in there. And before Windows kind of existed, this console used to be the operating system. So if you look up DOS or MS-DOS, Microsoft DOS, and you see the pictures of this in terminal or command prompt, used to be like this. And Windows was actually a thing that was overlaid on top of the OS. Right? So that's pretty much why it's called Windows, because you have Windows on top of other Windows. And Mac is pretty much the same thing. So this console.log allows us to access the commands in command prompt or terminal. So this console.log thing is actually a function. And, a JavaScript's an object-oriented language. And if we do console.log, it's actually just calling a function called log inside of the class console. So if you imagine we have console class like this, and this is just kind of pseudocode. We had a function called log, and it took input. Let's say we're doing it in C++, something like that. This function log actually has a function called printf, which I'm sure you've heard of before, right? And then printf, if you think about this, like these aren't magical functions. A programmer had to make these. Printf has a function that I forget what it's called exactly, but it's in assembly. And that assembly has a function that prints to your screen. And that assembly function has something that will turn on the pixel on your actual screen and draws out whatever it is that we're seeing, right? So these functions all trickle up. The cool thing about Node and again, JavaScript is the console.log allows us to do this without us turning those pixels on ourselves, right? So console.log. I just like to say it sometimes because we take for granted, Node and JavaScript and even printf of all the work that's happening in the background that, again, developers create. When they make the operating system, someone has to write code to turn on that pixel on your monitor, right? It's kind of cool. So with this, we have a bunch of other stuff that we can access, like console dot whatever is in here, clear, count, info, table, whatever. And we have some of these built-in functions like dir name, which will just show us what directory we're in, which is handy for things like when we want to access files. So in one of our assignments, assignment 3, I believe, we access a JSON file. We'll talk about JSON more. And every computer doesn't have the same directory. So we use these variables like a dir name, file name to get this data. It's kind of neat. And we have something else called set timeout. These are, again, built-in functions that we get right from the command prompt. What's set timeout do in JavaScript? Remember this from Web322, I hope? Set timeout. Obviously, there's a timeout or a timer of some sort. What does it do? Take a guess? Yeah, a ways to run what's ever inside. Yeah, there you go, right? And a lot of students don't get that. So this is a way to run code after X amount of milliseconds. Most people use seconds, but I'll show you in a second. Stupid. And it looks like this. And this is just a function. So this is in milliseconds, like you're saying. So, 1,000 milliseconds is 1 second. If I save this code, you'll see in the bottom, it's going to show hello world. And then after 1 second, it'll show the run after 1 second. You make it 3, whatever you want. So I bring up this one right away while we're talking about console. JavaScript is an interesting language because it is asynchronous. And that means, well, we're going to get into big detail of what asynchronous versus synchronous is in next class. But if you watch this code really quick, watch down here when I run this hello world is going to run instantly. Then this code runs, but it waits 3 seconds. And then this async code runs immediately after, but then it will display after the 3 seconds. So what I'm trying to say is this runs all of these lines of code as fast as the computer can run it. In the background, we call it a thread. A thread will start and will wait 3 seconds, but you'll see it'll say hello world async and then run after 3 seconds. Oops. Right? So JavaScript, and it should say after 3, whatever, doesn't matter. Right? So JavaScript doesn't stop running code. And if you check out CNN.com, which not an advocate for, in fact, the opposite, but check out console in here. And when you load CNN.com, this is their console, right? Because JavaScript is a client-based piece of software. And you can see that it has tons of errors. Whoever programmed this, they left the errors in, and it happens. And you can check it out as it keeps loading. It can't find an image. It has some other problem. But when you're actually looking at this regularly, you don't see any errors on the page, right? You just read the page. Everything seems to work. But it's very interesting that I can go in here. Well, this is because of the async nature of JavaScript. If we had to wait for these errors to happen, well, CNN would probably have better programmers, but you would never get to see the web page. right? It would just always be loading these errors. The CNN programmers suck, eh? Like, look at this, how bad it is. Anyway, async. We also have another thing called set interval. Similar function to set timeout, except for set interval will run forever. So if I put in a function in here, let's see, console. Let's say I want to count. Let's just do a count, right? So I can do bar count equals 0, and then count plus plus. What's count plus plus? What if count is an integer and I do count plus plus, what does that mean? Increments? Is that what you said? Postfix? Yeah, okay, it is a postfix, but what is it? Well, now I already said it. So it increments the variable, right? So I'll run this code real quick. Let's do it every 1 second. And this should just count for infinity, right? The bottom. But yeah, sorry, if you didn't know this, you should know it. But if I was to count manually, or this is counting manually, if I was going to do this increase manually, I would do count equals count plus 1, right? I'm surprised you guys don't know this. So I'd start at 0. This interval will go forever for every 1 second, and it's just going to add 1 to this variable. Because programmers are lazy, invented incrementation or decrement. You can actually subtract from this if we want. Right, and this would count backwards forever. We can make it work really quick. Right, if I do it every 1 millisecond, basically until my computer crashes or console runs out of memory, this would go. These things like this count minus minus or count plus plus, and we're going to come back to this in a second. It's called syntax sugar. It's a weird definition, but programmers are inherently seem to be lazy. I'm pretty lazy, but we're relatively smart, I think. And we usually make code easier so that, we make complicated code so that we can use it later for ease of use. I'll explain. Instead of writing out count equals count plus 1, people were doing this so often that they're like, I'm just going to do the plus plus at the end of it to make life so I don't have to write these 7 more characters. That's how lazy programmers are. And then I can do it right in the console.log. Right? Pretty cool. Back to square one. I'm going to show you some more lazy syntax sugar later. Let's see. Okay, so these are kind of the built-in functions. You can go back, and you're probably going to have to go back to see some of these, particularly dir name and file name in assignment 3. I'll remind you that you can go back here and check this out. This set timeout, set interval we'll heavily look at next week. Okay, C++, if I recall, when you include, I guess there, I just said it, when you add a file to your C++ program, at the top you put like include and then whatever the library is, right? So like, I think you do mathlib or something if you want to do mathematical instructions. JavaScript has the same thing. C# has the same thing. In C# it's called using, like you're using the library. In JavaScript, it's called require. So you require a module. And there's a few base libraries that are already pre-installed. So I'm going to show you one real quick. And it's called readline. I'm just going to copy and paste this. Actually, I'll write this out. So const readline. Remember, we only have var, let, and const, right, for our variable types. So const readline require readline. And why do we have this? So this allows us to enter data in the console. And the reason this doesn't come standard with JavaScript is because JavaScript is for clients, for client-based software. So it'd be pretty stupid if I invented or not me, if someone invented a software where I'd have to right click, go inspect, go to console, and let the user type in information. If you're making a web page, it's more likely you're going to have a text box that the user enters in data in. So a read line really isn't necessary for JavaScript, except for the person that took the V8 engine from Chrome and put it into Node. They're now like, oh, we need a way to get data in. On that note, you can actually do what I'm saying. You can actually go into console here and you can write JavaScript code like console.log hello world. And you can run it in console in the browser if you want to, but it would be kind of crappy to be like document.get element by ID and then enter your name. So anyway, we do this. So I'm going to take the whole line of code, drop it in. So this is just going to allow us to prompt us to do stuff, enter my name. Oops. Right, and now I'll put it to the screen. We won't use this even for assignment 1. There might be a lab on it, or might be in the lab number 1, but otherwise it's highly unlikely we'll use readline. We're not writing console apps here. I'm just using the console as a demo, and this is just a demo for how to include outside files. Pretty simple though. Any questions on that? Not difficult. Did you guys have OOP today? No, when's that? Tomorrow? Okay, well, here's a precursor. So JavaScript is object-oriented. What is object-oriented programming? What is that? You had a whole semester. What's object-oriented programming? Any idea? Physical object? Yes, I don't know. Well, we're not 3D printing. But I know what you're saying. Physical object. What is it? What's object-oriented? Think like it's broader. Don't chat GPT it over there. What's object-oriented? What's an object? Like, how do we get an object? A lot of attributes. Yeah, right. Yeah, a lot of attributes, properties. Yeah, right. Remember the word. I can say the words too. Constructor. Right. Classes. What's a class? What's that? You got to Google it first. What's a class? What's object? Like object-oriented programming. Remember, like there's a couple different programming paradigms. Object-oriented and procedural is the two main ones, right? So a procedural program, if you think about it, if I wanted to create a program about a person, we could have, I don't know, I'll just use JavaScript, var first name equals Harry, right? 25, yeah, I wish. And let's say I wanted to make a second person, right? I'd have to take all of this code, make another person. I'd have to make a new, variable. Let's say I want to make a third one. Maybe I make a typo by accident, something like this. And it can get pretty sloppy pretty quickly. This is procedural programming, right? It all runs in order. If I want to do an object, I would probably make a person object, and I could put in all of the variables inside of that object, which is what you were getting at, right? Encapsulation. Yeah, perfect. You Googled it. Get out of here. Okay, encapsulation. I'll give you it. Encapsulation. Just so you know, whenever I've hired a co-op, and pretty much anyone I ever known that's hired someone, their first question is, what is object-oriented programming? Because that's what you're probably going to be programming in, right? React, Angular, C#, C++, Java, Swift, Kotlin, all object-oriented. They're going to ask you this. And they'll ask you those, like, pretty much what I'm going to cover right now. So anyway, I put this in an object. So it's like grouping everything together. We call it encapsulation. Makes life a lot easier. So I can show you some of this. And JavaScript is unique in that it's very forgiving. And we saw this in the demo of these stupid CNN programmers who, I don't know how they got this by any department of software testing, right? Like, how does it fail? Any of these failures not acceptable, but it's so forgiving that the website still works. The same can apply over here, which is kind of weird, but it's kind of cool, I guess. Anyway, I'll come back to why I'm telling you that. So in JavaScript, we don't have to specifically say that we want to have a class, although we're going to eventually. But we have something called object literal notation. And it means that we can create or make up our own object on the fly without doing a class. So I can do something like this. Right. And now if I do console.log, hopefully you know how to access these properties, but I can say that whatever the object is called, this is the object person, and then the property first name. So this should output Harry pretty easy. And notice, like, again, forgiving. I didn't even put a semicolon to end the line of code. The code still works. Now I put it, still works. I'll show you more things of why it's kind of crazy, but hopefully this makes sense. So this is object literal notation. Has anyone seen JSON before? You saw it, right? Like last semester, probably. Like I think you guys even did it in my class, right? So JSON, if you weren't in my class, I feel sorry for you, but you know, this is kind of looks like this stuff. All right, this is just a crypto API call. Basically, the world runs in JSON. When you open up your iPhone or Android or whatever Windows phone, when you open that up and you open up Instagram, it sends a request as an API call like this, or it gets a request. When you open up your crypto app, in particular, this one is going to send back all the crypto data. And just notice that it looks very similar to the notation over here. The reason why JSON exists, and we'll get back into that later in the course, is basically all these JavaScript developers used object literal notation. So everyone conformed. So now it's really easy to consume this stuff because it almost looks identical to the object creation over here. Anyhow, let's go back to this code. I'm showing you some of these things that we might not even use. In this class, we're going to use classes more, which we'll get into right now. So I'm going to convert this to a class. I'm going to make a person class. And it's pretty much like, again, I'm not a C++ expert. I'm a C# expert, but I think it looks probably similar. First name, last name. I think in those other languages, you have to strongly type it, right? String, int, double, whatever. JavaScript's a little bit easier. So if I have a person class, and how do I use this? So we said some of the words, right? Instantiate. How do I instantiate a class? Yeah, right. If you were in C#, I think, or C++, probably be person equals new person, something to that effect. In JavaScript, obviously, we only have var, let, and const. So we don't declare the first variable, or first class. So this instantiates the object. Right? And then I can have person.firstname equals Harry. And then the console.log person.firstname. So yeah, that OOP class, it teaches you way more than this, but this is probably the most important part, these objects. How does this work? Like how does this work, I guess? Why does making a new person, what does it do? You ever think about this? Create a new instance. Yeah. And what does that mean though? Like, what does it creating a new instance mean? You're right. It's just, what does that mean? And I'll go to trusty old MS Paint to describe it. But what does it mean? There's so many ads on this now. What the hell? It's because I've used it so many times. At least they're not the ads what I was really Googling earlier. Forget it. What is an instance of an object? Or like what happens? What's that? Not copies. Not copies. But good guess. Anyone? Any other? So what happens when I make a new variable? Let's say you're in C, right? and I make a new variable int age, where does this go? New memory, right? Pretty close. Alloc. Yeah, what were you gonna say? Same thing.
Setting the variable as
At some memory location. So remember, like C, I don't even know C syntax anymore, but you have to allocate memory, right? And then at the end, you have to deallocate memory, which is, and if you leave that open, you have a memory leak and everything goes to hell. Well, this is the same thing that happens. We're just creating memory by instantiating an object. And again, this is a common interview question. What happens when you instantiate an object? Well, these are just places in RAM that are being created. And now I have that memory location. We called it person, but it's like 0xA5, whatever, right? Anyway, so we create that in RAM. And if you think about how like difficult this looks, now you guys are a little bit more seasoned, right? But when you think about how, like, why is it var person equals new person? Well, think about var first name equals Harry. Like you would know immediately this is a variable, even if you've never even really seen JavaScript before. If you've never seen object-oriented programming, you might think, oh, like this is so weird, but it's not. It's this person, and then the two brackets at the end is just a function, right? So function initiate, right? So if I was to call initiate from anywhere in my program, I would just say initiate, right? So person is actually just a function, and we just give that function a special name inside of our person class. What do we call it? I said it already, right? Because we build stuff. The class is a blueprint, and then we make it. Close. We make an instance, but how does the instance get made? It's called a constructor. You heard of this before? So constructor looks exactly like this. And why it's like, I don't know about C++. Again, you can ask your OOP person, but in newer languages, C#, Java, this in particular, because a lot of times you just make, you don't want to do anything with this person class immediately. They call it a blank constructor.
default.
Yeah, default, whatever. Yeah, default. There you go. Thank you. So this is our default constructor. So I don't have to put it in here, but in reality, when I run this code, it's in there. You don't see it as the dev. Syntax sugar. 20 years ago, you had to put in the constructor. But I can prove that this runs. It's console.log hello constructor. Right. If I save this, you can see there's my hello constructor, which is just this function person getting ran. Right. And we can do other stuff in here if we want to, whatever. Default constructor. So again, class, which is like the blueprint. An object is what happens when you instantiate the class. You have your constructor that runs before your class is made. So those are the four things, I guess. I think there's one more. I can't remember. Doesn't matter. Okay. So we have all this stuff. I'm going to get rid of this constructor. Again, this is a refresher. Yeah. Nice. You're reading forward or something? You want to teach the class? No, that's what I'm going to next. Yeah, great question. The question was, is it private? Is it public? I'll get there shortly. Okay, but that's a great question. I like where you're going. Okay. Hold on one sec. Now you threw me off. I'm like, oh my God, you're smart. Okay, hold on. So like got the class person, blah, blah, blah. Let's see. Okay, yeah, let's talk about private and public. Okay, so in C#, C++, I think you have to label these, right? Public, private.
You just set it
Under below it. Yeah, okay, that's cool. Again, I'm not a C++, but that seems like you have to set it. Same happens for private. Okay, cool.
Well, so if it's a class or
Class or a property in a class. Okay, I'll refresh. Sorry. If I do this, that sets everything in the class as private, correct? No? I don't know how C++ works. Yeah, within the class. This one, the other way? Okay, doesn't matter. I don't care about C++. But point is, you have to define public or private, right? So in programming languages like C#, C++, if these properties are private, I can't access them outside of this class. And we have to have something called accessors, right? So that's the fifth one, accessors, objects, accessors, whatever, it doesn't matter, there's 5. So accessors are gets and sets, right? So if I want to have accessors in here and I want to access first name, I would have something like set first name. And this is a function. And I'm going to pass in a variable. And I'll do this. Actually, I guess this, I don't have to put function, sorry. Yeah, we'll come back to this. It's not, this is this. It's fun, right? Okay, so then we have this. And then if I want to get the first name, oops. Here you go. Okay, right? So for every one of these properties, we need these accessors. In JavaScript in particular, at least as far as I know right now, if these are marked private, you can't access them without these accessors. So basically what I'm saying is, oh, sorry, yeah, what am I trying to say? So many things going on. Down here, this won't work anymore. Person.firstname equals Harry. I actually have to say person.set first name, pass it in as a parameter, and the same for get. Now here's something screwy, and we'll come back to this. And there's actually in JavaScript, there's something called that, this and that. It's so stupid, but we'll come back to it in a minute. But check this out. Okay, so in this set of code, I'm going to mark these as private. And you can see it's kind of weird because, and hopefully you can see it, I have instantiated a new person, I set first name, and then I use console.log get first name. But I also have console.log person.firstname. In JavaScript, you don't type private, you put a hashtag, or in old guy speak, a pound sign to mark things private. But down here, I'm saying use the accessor and also access the memory directly. And the output at the bottom works. But I just finished saying you can't do that. So why does this work? Couple things. This attribute. Any idea what this does? Yes, yeah, points to the current object. Again, OOP, you should know this, or they'll maybe teach you this year. I don't know. I thought it's like one of the first things, but this will refer to everything inside of that object, or in our case, this class that gets turned into an object. And they do this because originally you would set your accessors to look like something like this, which is super confusing because when you glance at this really quickly, this is a function. I'm asking for a variable first name, which in C# or whatever, C++, it would look maybe something like this. So this first name is only in the scope of set first name, and the first name, this one, is in the scope of the entire class, which is weird. I like to change the name slightly, like underscore. Then I really know that this one is only reserved for set first name as opposed to the first name over here. So you just got to remember that this keyword means anything that's inside of this class. And then if you don't have it in the function name, it's whatever's inside of that function. So weird things that happen. For example, I'll just show you. Notice that, here, wait, I'll run the code and I get these two outputs. And I shouldn't have them. One of them should not work because I'm asking for this first name and technically it's private. And this is where this JavaScript thing comes in. So I'm going to go back over here. And as you know, everything we write in software, everything you use, I would say everything, except for everything you write, has a version number. And when you change something in software, the version number typically increases, right? So you have a version of your OS. There's always like a number that's super longer that you don't actually get to see. JavaScript is still software. Developers write that software, and every time they release a new version, JavaScript can do something new. So there was a version 1, 1997, right? It was like 10. And all the way up to now, we're at ES6. And they do have numbers, but they go by the majors. So ES6 and then ECMA script 2020 is the current version of JavaScript that we're using. But when you write code and all these people are using it with browsers, because JavaScript is meant for browsers, with browsers that are totally outdated, right? If you go to a bank and if you ever work at a bank, which I did for NFC payments, they had Internet Explorer, like the oldest browser next to like Netscape. And they were still using it like 5 years ago. And only certain versions of JavaScript work on that. So when you write code, your browser has to be able to render JavaScript 3 as well as JavaScript 6. So Node has this same fault. Shit. Nice. Good timing. Not really. Hold on 1 second. I do have to fix. I found a fix for that and I forgot to bring it, but whatever. I know how to fix it quick, I think. Hold on. I think the Skype people lost the screen. There we go. Okay, we're back. Okay, so a couple things with this. What was I saying? It has to work on all of these old browsers. Node, obviously, it allows us to use JavaScript in our console. But here's back to this versatile thing and all of these errors. And this is stuff you're going to run into as a JavaScript developer because it's kind of difficult to debug JavaScript. So notice I set my variables to private. And then in my accessors, I didn't use the private names. I actually used this.firstName. So when I do this set first name over here, I'm actually creating another memory location called first name that's public. And when I get first name, I'm also getting that public first name so that this line of code down here will actually work. That's why I get Harry and Harry down here. So I actually have to reference these as private variables. And now when I run this code, you should see, hopefully, fingers crossed, undefined. And that makes our variable private. Just JavaScript is forgiving. So I made that error. I could actually make this whatever. Say there's a typo, right? Erst name. This will actually go to the RAM, make a new thing called Erst name. And if I went down here, change this to Erst name, it should show me Harry, which it does. So be careful because we deal with a lot of classes and stuff like this in this course. And it's like real easy to screw up. Your code works. My code works. There's no error. It says undefined, but there's no error, right? So be super careful and it can be really frustrating. Like I spent days on one hashtag and didn't find it. You know what I mean? It can be so frustrating. And that's a good time. Like I say, don't cheat in my class or I'll just murder you, literally kick you down a flight of stairs. But you can show your code to a friend and be like, just take a quick glance to see if you can catch anything. That's when I usually find stuff, or like people find errors in my code. He's been staring at it for so long. Anyway, before I move on from this, the last thing, why do we care? Why do we care if a variable is private or not? Ideas?
Access by other functions.
Yeah,
Or
or
by other objects.
right? Well, just as easy as I can access this first name or Erst name or whatever. My program can access basically anything in memory, right? So if we go back to I don't know, one of these, right? If we draw like a stack is like RAM. So, you know, in your computer, when we create a variable, it kind of looks like this, a very, very rudimentary drawing. And this would be the memory location. And this would be whatever the value is, right? So when I create a person object, it's going to go to memory and whatever insert, we'll say first name, and let's say even password, right? And then in the value over here. So if these are marked as public, it means that not only my program can access this stuff, but programs all the way down here, if they know the memory location, they can access this piece of memory. Now, what's that? Yeah, you can steal passwords. And like, so it's built into this, into the assembly, into the machine language of your program, of your computer, of your OS, that if this is marked private, then you cannot access this memory. But if you mark it as public, you can. Anyone have or know what rooting an iPhone means? Or jailbreaking? Yeah, what has ever heard of that? You've heard of this term, right? Jailbreaking iPhone. What does it do? What does jailbreaking do?
Give you access to all applications for free.
Yeah, pretty much. Or you can install applications for free, right? So you can download, because these are like, it's not like they're cloud applications, they're still physical applications that you put on the phone. Jailbreak, you ever hear of jailbreaking or rooting like a PlayStation? Things like this, where you can put in a mod menu in Grand Theft Auto and make everyone a tree. It's hilarious, right? Well, this happens because, what's that?
R4.
R4 DS? Oh, what is that?
Download.
Oh yeah, gotcha. Right, the same thing. So like yeah, right. But some programmer made that, and the way they make that stuff a lot of the times is this access to memory, and they can do stuff like inject code directly into this memory location. So if I have a program that's running whatever, this program, and I'm just expecting console.log Harry to be outputted, but in reality, it's some other exploit where it's like actual code. If something, blah, 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 whatever it is, instead of outputting Harry, the program's going to run this code. And these exploits work by that. So people are allowed to run code, even though that, you know, their class might be marked as private. Some of these, the developer forgot that one because they were hungover or whatever, right? So kind of cool. This also happens a lot in SQL, and I may have shown you guys this last semester. Something called SQL injection. And I know you guys have taken SQL. Imagine you have select star from table person or from person, where first name equals Harry. All right, simple select statement. You guys should all know this, right? Well, imagine Harry is not Harry. It's in our code and it's plus person ID or person dot first name. And my code kind of looks like this now. Well, imagine I don't set first name to Harry. I set it to drop table person. So now when I run this code, and I could to make it work, I'd have to maybe close that, put a comma, whatever. But now I can run the select statement, and I don't care about the first one, but I also run drop table person, and it drops all of the person table because it's a hack, right? I've inserted it. I could also do that by inserting it into memory, right? I can insert that malicious code. And that's how these hacks work. This is I don't know how this has gone around for years and years. Someone figured out that they could print out SQL injection on the front of their car so they could just drive through speed cameras. And every time it drove through the speed camera, it would drop the SQL table. So they never got a ticket. It's genius. Yeah. It's genius. Total genius. Another one, and these are true SQL injection attacks. They're still relevant today. It's how a lot of websites get hacked. Another one was a guy printed, or he got a customized plate that said null, N-U-L-L. And kind of genius, right? Because it's illegal, but or it's legal. But what happened was in the database, he didn't not get tickets. He got every ticket that was ever for an invalid license plate. So he was getting thousands of tickets every day. Yeah, millions of dollars of tickets because his name was null, and now it had a null had an address. So yeah, it backfired, but similar idea. Anyhow, so this is why we mark those private, and it's also why we have stuff like these accessors, because this accessor is a function. So I can do stuff in here as a line of defense, like if first name dot length, is greater or greater than 20. I can say console, or I can do throw new error. Name is too long. Else I can actually do my set. Right. So these accessors are handy for making sure you don't have null as your license plate. Pretty cool, right? Let's see. What else? I'll put this back to basics. Another point kind of getting at, there's so many ways to do stuff in JavaScript, like I showed you, the object literal notation, even like different private settings. This class would still work. I could write a whole program, and you might write a whole program like this. And if the assignment specifically doesn't say use accessors or private, then you would still get full marks on this. But what I'm trying to allude to is that it would almost be impossible that anyone in this class would have the same code as someone else, because there are so many different ways in JavaScript to do this stuff. And that's how you get caught basically cheating. But just be aware, JavaScript is super forgiving. Anyway, yeah. I need a beer. Inheritance. Your grandma died and you got a car. I don't know. What's inheritance?
Deriving the last from another class.
What's that?
Deriving a class from another.
Yeah, exactly. Deriving a class from some other class. So say we have a class and it's a player, like sports player, right? And we're going to keep the team name in here and I don't know, player number. Right? And I instantiate a new player object. And I set the team name, whatever. Something like this. And I also want the first name, last name, and the age. Well, first instinct would be to just put these properties inside of the player. But imagine you had thousands or hundreds or even thousands, whatever these properties, or even you had functions in here. Maybe I have a function that is, I don't know, that does something, calculates something. Well, I don't want to do that. So it's called inheritance. You probably remember from C++, and I think to inherit from another class, you use a semicolon, and then whatever the class is called. Something. Does this look familiar? In JavaScript, it's called extends. So this is a syntax for this. Oops, person. So if you didn't know this, we can use now all the properties, first name, last name, and age from person, as well as team and player number. So it's handy for sure. Let's see. Any questions on that? Objects? What do we got for time? Let's damn it. I have to stretch this out for 45 minutes. Okay, test. No, I'm just kidding. Yeah, questions. Thank God a question. Yes. Say it again.
You have to delete objects to avoid memory.
Good question. What's that?
Destructors.
Destructors? Is that in C++? Yeah, okay, that's cool. How do those work? The question, if you didn't hear, was do you have to erase or destruct the classes? The answer is no in JavaScript. And in Java and C#, the answer is no. In C++, I guess the answer is yes. But I should say this, it's no kind of. So, programmers, lazy, super lazy like that. Why? Or like, not why, I know why. But how did they get around this? So if I have a deconstructor, sounds like a transformer. Okay, yeah. So destructor, deconstructor. Really, destructor? Okay. Your OOP guy's a moron. No, I'm just kidding. Destructors, that's cool. I don't know, C++. So anyway, there's a thing that JavaScript and more in particular C# and Java that they do so that you don't have to do this. And it's called garbage collection. I'm gonna type this in. I'm gonna get a garbage man, probably, but whatever. Let's do a programming. What is this? Yeah. So what's happening is if you're in Windows, I don't know how to do it in Mac. If you're in Windows and you right click and you go to Task Manager and you see Chrome, all the instances of Chrome running, and you can see some of them are filled up with like 500 megs of RAM or whatever it's using, right? Well, what's happened is someone has written programs and you've been to websites and they filled up classes or whatever with memory. And your computer is like, I don't really have a use for this memory anymore. So I'm just going to let it stay there. But eventually a system tool runs and it cleans that memory out for us. So we don't have to deallocate memory or we don't have to do the destructors. And it just works kind of like this. So it's called garbage collection. It happens in C# and Java, and I believe now Swift and Kotlin and other languages. C++ probably has it anyway. So specifically, I could have just said no to your answer, but no, and this is why. Because it still does clean memory. And by you guys going into Task Manager to get more RAM, that's like you're forcing the garbage collection to happen. Okay. So, but yeah, specifically, no, we don't have to worry. We don't have to care. If I instantiate this as a new person, eventually it's going to go away if I stop using it. And thank goodness, because like I hated that stuff. Allocating memory, it's like the worst. You get a memory leak. Very early iPhone apps would crash your iPhone all the time because you get a run on, which would just fill up the iPhone memory and crash your phone. Because developers hate Objective-C. At least I did. Anyway, other questions? See, that took 5 minutes. Thank you. And I knew the answer. Yeah. Are there virtual functions? Well, what's a virtual function do? Now you're just asking questions for the sake of it. There are interfaces. That's a good one. I'm not 100% certain. We'll look and come back. I'll get back to you with an answer. I've never used them in JavaScript. So the question was, if you didn't hear, are there abstract functions or methods or classes? I would say likely yes, but I don't know. I'll find out.
Function or class.
Okay, this isn't question period. No, I'm just kidding. Go on. Yeah.
Function or class templates.
I'm not sure. Again, I'll find out and get back to you. Hold on 1 second. Just writing it down. Those are C++ things, but abstract classes are usually in every object-oriented language. So I would assume that you could do that. I've never used it in JavaScript because of how it makes objects. Like it's so much easier. I don't need to abstract a class because it's already abstract. You don't have a string or an int to abstract or an object. They're all objects. But let me find out. No one's ever asked me that. So I'll find out for you. Okay. Other questions? Don't just ask for the sake. I'm not sure either. Okay. All right. Okay. Laziness. Let's talk about that again. JavaScript. I can put functions inside of variables in JavaScript, which was a real weird concept to me when I first learned about it. And I can do something like this. Right, hopefully you can see this. So this would be actually the same as just having a function and then calling it. Oops. right? Something like this. And if I did console.log, this should give me 9, I'm guessing. Which it does, right? So, but I can set this to a variable name called adder. And it's important to know, and not necessarily for this class, but in the future, React, Angular, they constantly pass information via a function as opposed to via a variable. It's really weird. But yeah, we can do this. Now, syntax sugar. And I hate it so much in JavaScript because there are so many ways. There must have been a bunch of nerd developers hanging around being like, I want this my way. I'm going to tell my mom. So I can make this function work with like half the amount of code, but it's so silly. So someone was like, I don't want to do this. I don't want to write the word function because I'm so lazy. And instead of writing the word function, I'm going to do this thing called an arrow function. And so instead of typing the word function, I can type arrow, which it looks like an arrow. It's actually derived from something called like a lambda expression inside of calculus, where you can put functions inside of functions. But anyway, if I run this code, you'll see it outputs 9. So I get to save my fat fingers 6 characters from typing function. But also, I can also not have the word return. So I can put this whole function on one line, still outputs 9. And again, this is syntax sugar. It's the same exact thing. When I run this code, same memory location, same overhead, just syntax sugar. So once I'm not like, as you can see, I can't answer all the JavaScript questions because I'm a C# expert, but there are syntax sugar things in C# that I'll use, like to make my coding really fast. JavaScript developers are the same. They'll use this. So technically, if you wrote a bunch of functions all at once, this would be quicker. But it does come with some caveats and some things that they fixed, which I'll show you in a second. But we can get even crazier. Let's say I have a function with no parameters. It looks like this. Right, so it says let adder equals no parameters, the arrow, and then whatever the output is. Yeah. Oh yeah, exactly. Yeah. Isn't that crazy? So that's why, like, again, really easy to catch. Like, I hate harping on it, but so many people cheat, but to catch cheaters, because the errors like this will work. But like, even look, I didn't even realize that I left those in and it worked. Right? Syntax sugar. Other weird things. Let's see. Oh, check it out. Here we go. And I didn't even look at this. Deconstructing. We'll get back to that. Let me look at that. No, that's not the same thing. I'll shut up now. Okay. Let's see. Okay, check this out. This one's fun, or not fun, but weird. I don't know if this will work. Maybe not. Hold on a second. I'll come back to it. Doesn't matter. Arrays. Let's talk about arrays. I have an array. Bar some array. Hopefully you guys know what arrays are right now. If I want to iterate through this array, you don't have to give me the exact syntax. How would you do it? For loop, right? Okay, so let's do 1 for var I equals 0, I less than what? So, yeah, right? Yeah, size, or in this case, it's length. And then I plus plus, or, I equals I plus 1. That's why that was invented, by the way, because programmers didn't like doing this, which will still work in this array, but I plus plus. And then how do I output it to the screen? One at a time. Yeah. Then what? Right, and what do they call that? What's that
This-
called? One?
What?
Oh, sorry, what do they call this? Yeah, indices, index. Right, so if I run this, it should output, which is fine. Pretty easy. There are multiple ways to do this. Right, yeah, what's up?
What if I print everything on the same line?
On the same line? I think you have to do a join. I'm not sure, but that would be stupid because you could just do console.log some array. No, I'm just kidding. But oh shit. I don't think, I think this gives a carriage return every time. What I would probably do is something like var output equals whatever. And then I would do output equals plus equals some array. And then after the for loop, I would do console.log output. Like that. While you guys were talking, right? I would make an output array and then I would just add to it. Yeah, and then just output the string. That's how I would do it. There might be a again, I don't remember C++, but in C#, it's console.writeLine gives you a new line, and then console.write will not put a carriage return. But because remember I said this JavaScript was meant for web browsers, so they probably don't even have that. So yeah, you'd have to do it this way. How else would I write? How else would I reiterate through the stupid sum array? Any ideas? A while loop? Yeah, that's super old school. Let's not go there yet. What else? Still while loop. While and do while, almost the same. One runs, right? A do while at least once. For each. You ever heard of a for each? For all, for each. Yeah. Okay. So we can do letter. I think is it in or oh, I guess you guys don't know this. Is it? Did we? Yeah, I didn't. Well, this is a reminder. Some people don't know. I didn't remember. Console.log letter. Right, so same. Oh wait, no, not the same. Why is it 0, 1, 2? It's not in. It's something else. Which I forget. Of. In gives you the index. Of gives you the value. There you go. Which is interesting too. Someone in the last class asked me how do we count in here, and I actually did a count where I did var count and then iterated, but I didn't know you could do in as well. That's cool. Okay, sorry. So of in this scenario, by the way, and in C# and C++ and Java, they have stuff like this. They're considered for each loops, and there's another for each loop I'll show you in a second. But this is actually a for loop like this when you run it, and then one step further, this is actually a do while loop before this one. So when you compile a program in certain languages, and if you use a for each, because a for each is syntax sugar, because it does it by this. And this for is actually syntax sugar because it gets compiled into a do while, which is syntax sugar for assembly because it gets converted into a go-to statement. If you've ever you've never seen a go-to the next slide. And kind of go-to is like a switch statement. You know what a switch statement is?
Yeah.
It's like that. So like switch to different ones. Interesting. If you ever get a chance, assembly looks like this. And IoT devices, Internet of Things. If you like that kind of stuff, you should take an assembly class. This is how your computer works. This is one step before 0, 0, 1, 0, 1, 0, 0, 1. It's cool, but it's difficult. I don't know if Seneca offers a course on this. Anyway, so we have these built in. We have another one. I think it's right in here in the object for each. Oops, shit. I forget what the syntax, but we can look it up. But again, point of why I'm showing this, and it's a reminder, just there's so many ways to do these things. It's very difficult to copy somebody, so don't copy. 5:30, but it goes to 6. We're almost done. I didn't give you a break or anything, but whatever. Okay, check this out. The name of this one is called spread in syntax. I've never seen this in anything but JavaScript. Maybe someone else has, I don't know. But we can have a function called sum. And imagine we had num1, num2, num3. And all this function did was add these three together, right? Return num1, num2, num3. Oops. Am I boring? Yeah. Don't come back. No, just okay. So, right. So I could add these up, no problem. I can do something like this. Oops. And this is get out of here. This is called spread syntax. And this just assumes that you're going to put as many variables as you want into this function. I guess they call it spread syntax because it spreads it out. I don't know. But let's do an example. Let's copy and paste it. Right. So this should work. Equals 21. I can put in more numbers if I want. Oops. Right. So a little bit easier than, I mean, in reality, what this is doing is this is an array, right? And it's automatically making this into an array, but it's just indicating that, yeah, I'm going to send in multiple numbers. Syntax sugar. Okay, last thing before I let you go. You've heard of tries and catches before? What do they do? Yeah, errors, but what do they do with the errors? What do they do? They catch the errors? Yeah, okay. Tells you the error, yeah. I like the words you're using. They catch and they throw and stuff like this. Yeah, totally. Okay, so ancient computer types. Before my time. You ever heard of something called the blue screen of death? What is that? PlayStation 4? Okay, right? Literally can't do anything. Used to look like this. In fact, people call it the blue screen of death on PlayStation, but it's not a blue screen. Was it? Yeah, no doubt. But before we had tries and catches, we used to have blue screen of death. And if you did something crazy, like divide by 0, or if I set a constant, or I tried to set a constant that's not a constant, or sorry, try to set something that is a constant, we used to get screens like this. And I remember this stuff. Again, I'm a little bit young for it, but this is what you used to see. So your whole computer would crash. Meaning if I wrote a program in here and it was wrong and it ran, for example, like this, const pi equals 1, 4, and I do pi equals 5. If I just run this program, I get a crash inside of here. But if I did this 30 years ago, I guess, maybe 20 anyway, you would get this. And your computer would break. It is easy to break your friends' computers because you could just send them malicious code. This is called a stack trace or a stack dump. Yeah, I used to do that shit all the time. I was like 10 and I would send them programs so I could open their CD-ROM without them knowing. That was awesome. Anyway, you can't do that anymore. This is a stack dump. So these are the memory locations like I was talking about before, right? In the RAM, when that memory is on the left-hand side and then the values in the other side. So this is just telling the developer where the problem is in memory, which still happens today. Microsoft It was Windows 95 when they started to try to solve this problem. And we used to get messages that were more that looked like this. Not a big of a stack dump. But you ever been playing PlayStation and you get an error in a game, or you ever been in an app, either on your phone or your computer, and it says, would you like to send this debug thing or record to the developer? There's like a send button. You ever see those before? Well, they're actually getting the stack trace, the stack dump. And the only way they can do that, and this eventually turned into like a sad face. They thought they were being funny. But they invented these tries and catches. So inside of a try and a catch, I can do stuff like mitigate the risk. So check this out. EX. Okay, here we go. So I'm going to run this code. And instead of showing the error, I'm just going to say something like, whatever. Oh, shit. All right, so I run this code. It tries to set a constant to 5. And you can't set a constant. So I've captured the error. The computer doesn't explode. I don't get the blue screen. And the reason is because I have these tries and catches. But I can still have access to the error. Right? Console.log EX. So if I run this, excuse me, I'm sure people on Zoom would like that. I can still see the error, right? And this is the part where, I could actually write software that says, I'd probably have something nicer than oh shit, but I could actually say, open the email application and then send the error to the developer. So we don't break the person's computer. They get a friendly message, right? And then we also get the information of how the program crashed. So these tries and catches were created specifically for this. Now check out some of the error messages. So we talked about throwing errors, right? So there's this thing you probably seen. Did you guys do this in C++ or like just barely? No, not at all. Okay, so we can do something called throwing an error. New error EX. Oh, did you? Okay, sorry. I taught that somewhat. Well, in case you didn't do this or you forgot, you can throw an error. Did I do the blue screen example in 222? Shit. Well, these people don't know. Okay, so we can throw an error, but check out these errors too, right? These are students. Sometimes they come up to my desk with a computer and they're like, my code's not working. And they don't read the freaking error. It says right here, it says error, assignment to constant variable. They're like, I don't know where that is, but you got to read the error message a little more. So this one tells me, if I look at this, it's happening inside of an object. It's happening in this file, the server.js file, and it's happening on line 8. That's what this little 8 means here. And the 11 is how many characters in from that line. So we can actually, I'll just do it like this. Line 9. So this is where the exception is being thrown in my code, right? And if we look at here's line 9, and if I go over 11 characters, you can see there's my EX. Right, so this gives me the error. And then right here at the top, it will tell me like whereabouts it is. But what is all this other crap? And I'm sure you guys knew this. You must have known this because that's how you find your errors. But what are all these other things? What are those for? Why do we care? It's almost a stacked up stack trace. What is this? Did I teach you that? Bullshit, I did. You just forget. Maybe. Okay, well, when you throw an error, right? So like this try catch thing revolutionized parts of programming because we don't lose our computers. They don't go on fire. But remember at the start of the class, I'm like, console is used from that system32 folder. Kind of. It is. Let's pretend it is. And console probably has tries and catches in it. So when they were coding console, it was in this main module, which is on line 23, indent 47. And there was an error there because that's what manages setting variables. So there was an exception because we tried to set it. And then this it caught the error and threw it up, threw it up. Yeah, sometimes it throws it up to the next module that it was running, which is this run main. And then run main throws it up to loader, so on and so forth until we get back to our code. And eventually we get the output of the screen. So throwing an error usually happens when you're writing like libraries, and we don't want to necessarily handle the error. We just want to throw it to the next thing that will handle the error. So it's like a tree of errors. So for example, I can do errors inside of errors, which is kind of interesting. So I can do try, this won't actually work. We'll do this. So in this code example, this would be rarer that you would do this. There's a try, and then it's going to try all the code inside of here. And then inside of here, it's going to try all of this code. This will throw the error to this catch out here. Kind of confusing, but your OOP teacher should teach you this a little bit better. Before I let you go, this one thing on tries and catches. Try catches are the last line of defense before there's a blaze of fire in the system, before you get a blue screen. So do not use tries and catches as if statements. And it's tempting to do. Yeah, you have a question? Yeah. How do I what? How do I count them? Just like, I guess, spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know. I guess that's where it might be where the actual where it instantiates the object. Yeah, this is because we're throwing the new error. Let's try it without it. Okay, so this one says 3 and 4. So this would be line 3, and then 1, 2, 3, 4. In programming, you got to remember there are no spaces typically. So like this code would run the same as our last code. So if I save this, it should be, yeah, line 1 and then 17, which would be 1, 2, 3, 4, 5, 6, right? 17. What'd you say? It's not an array. I mean, I guess 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be 17. Yeah, I guess so. Sure. I'll buy it. Start from 0. I like personally, I wouldn't do that. I would just go by this first number, what line number it is on. I rarely use this, but it is there for that purpose. But I would never use that. I would always go by, like, you're not going to be, please tell me you're not going to be like, hey, where's the error in this line of code? Right? I understand exactly what you're saying. I rarely use that index. And I don't think I'm wrong. I'm off there wrong. So maybe that 11 means something else, but I'm pretty sure it's the count. Check, prove me wrong. I like it. And then you get the hell out of my class, though. I'll come back to you. I have a couple notes to figure out function templates, and then we'll figure out the error codes. I don't know the answers to all of the things. What was the last thing I was gonna say? Oh, I did that. Oh yeah, if statements. Sorry, there are other questions? That's a good one. Don't use tries and catches as if statements. If you're like, this will be pseudocode. We're almost done anyway. He's gone. Imagine I had input, like ask the user for a divisor, and then you do the function divide, right? The user enters in 0. This would cause a crash, and the try catch would catch it. But as a programmer, you want to put in something that says if, input, yes, greater or less than or equal to 0 or 0, right, then call them an idiot. Idiot, right? So don't use your tries and catches when you know there could be an error and it'd be easy to get to. The try and catch is just for the last resort. Okay, that's it for today. You can go home. I can go home. I can sit in traffic for 3 hours. It's awesome. I don't want to. Wait, bring it up. What is it?
You could send that.
Oh yeah,
Yeah,
they would
yeah.
crash their whole iPhone. Yeah, see the same thing.
I love.
That's a great example. Can you send me that?
Yeah.
Yeah, send me it because that's a great example. He just showed me there used to be like a text message you could send people. Like, yeah, on iPhone and it would crash their iPhone. And it's the same exact thing. Yeah, it is. Well, it's funny until you get it. Right?
Pissed off.
Yes, don't do that. Don't accept messages from him. Okay, yeah. Don't have to be here on Wednesday if you don't want to be, but that assignment is released. You should be able to do it in 20 minutes. Follow the instructions. Otherwise, you guys have a great week. Thanks for listening. See you later. I'll be here. Maybe. No, I'll be here. I'll be here. If you're not here, though, you're in big trouble. No, just kidding. That's it. Oh, yeah. Thank you for always forget.
I'm gonna send it an off topic.
Yeah, sure. That'd be awesome. Be awesome.